All right, class, this is finally 14.3. This is an exciting section that I think you're going to find really helpful and valuable to learn. So it is about causes and effects. So it's all about ideally in this world, we're trying to explain things around us. Why does some people get cancer? Why do some others don't get cancer? Why do some people get COVID and others don't get COVID? Or why are some people asymptomatic? Like we want to try to explain things around us in hopes that we can prevent, people from getting sick or just, prevent bad things from happening by predicting them and understanding them. So that means that we need to try to see, does living under power lines cause cancer? So, or in my question I have here, does coffee drinking lead to better health? Or in general, we want to ask, does X, call it whatever it is, cause Y to happen? So X is called the explanatory variable or the treatment. So the coffee, in the example before, it says, does coffee lead to better health? So coffee is in question, the one that we're thinking it might cause something else, right? Okay, and then Y is what we call statisticians call Y the response variable. It's happening as a response of the explanatory variable. So the response variable in the problem in this question above, does coffee lead to better health? The response variable is better health. Or you might call Y is like the result of X happening. So there in real life, when we think about coffee drinking, we want to ask that question, does it lead to better health? There might be a lot of other factors that lead to better health other than coffee drinking, right? So we know a lot of them, like exercising, eating healthy, right? Genetics or whatever. There's other things, maybe being exposed to pollution, whatever. There's other things that cause good health other than coffee drinking. So those are other factors. And a clinical study here, or a clinical trial, is a study intended to demonstrate that a specific treatment, and this is usually a clinical trial, clinical study, is usually talking about a drug treating a certain illness or disease or symptom. So a clinical trial or a clinical study is a study intended to demonstrate that a specific treatment is effective in treating some disease or symptom. So to set up a clinical trial or a clinical study, or I would just call it also in some textbooks, it's called a designed experiment. What you would do is you need to form two groups of people. You need to form the treatment group, and I have a picture of some of this stuff over here. Apologize. So what you do is you form a treatment group. So here's your treatment group on, well, first of all, you get a lot of volunteers, or not volunteers, but you sample people to actually be in this experiment, right? And from those sampled people, so maybe you started with the sampled people that you wisely chose a sample using the methods that we talked about in the prior section. And from that sample of people, that are going to be in your experiment, you put half of them ideally in a treatment group and half of them in a control group. This treatment group is the group that's actually going to be receiving the real drug or the coffee, if that's what's in question, that we think that makes and then we have a control group, and we just have the control group around to compare with the drug group. Because if at the end, if we say, okay, look, it does look like people's health improved, they'll be like, well, how can you tell it improved from what, right? So the control group serves as a baseline. This is what the average person, how their health would be if they were not taking the drug or whatever. And compared to the person that is taking the drug. So that's why we have a treatment group and a control group. Then the treatment group receives the treatment or coffee or whatever it is, or drug. And then the control group, we usually give them something that's called a placebo. Now, we give them a placebo to make them think that they are receiving the drug. And the reason why we do that is, let me go back to the other page, that because there's something called a placebo effect. A placebo effect is a psychological effect that occurs when, and it's just that they found a lot of time ago, research shows that if you tell someone that they're going to be receiving a drug and that it should make them feel better, like they're so optimistic and joyful, and that joy and optimism actually makes them feel better. Like, so maybe if you were trying to, like see if this drug gets rid of this headache, if you give somebody a placebo, which is usually like a sugar pill, it looks like the actual drug, but it's not actually the drug. A lot of times those people will report, I feel better, my headache went away. And maybe their headache really did go away because they, like maybe they were so excited they're going to receiving this drug, that they were receiving this drug, that they went out and exercised, and the exercise made their headache go away or something like that. So, or their joy and they're got so, I don't know, anyways, but they feel better when they didn't even get a drug. And that happens for whatever reason. So to make sure that everybody thinks that they're getting the drug, that one group is not going to obviously be depressed and be like, oh, we're the ones that didn't receive it, we're not going to get better, and then maybe be depressed and they would maybe feel even worse than they already are. So like, we don't want that to happen. So that's why we give everybody the placebo. Oops. So everybody thinks they're getting the drug. So any positive feel better effects that come from just thinking I'm going to receive a drug is even on both sides. So anyways, that is the placebo. That's why we want to give people a placebo. And what happens is there's actually some things that those other factors. So here's the other factors in the middle here. And these are things that we want to control. And when they say control, they mean make it be the same for both the treatment and control group. So there's other factors other than coffee that might make you have better health. And that's like diet and exercise, prior health, exposure to pollution, stress levels, all these other things that affect your health. Those we should try our best to make them the same for both the control group and treatment group. Because at the end of this, we don't want to hear, well, the treatment group, they were healthier at the end of this experiment, but we think it's because they actually exercised more, not because of the coffee. We want all of those other things that might affect their health to be controlled and we kept the same for both the groups, so that at the end, the only difference between these two groups is one had the drug or the treatment and one had the fake drug. So any difference in their health at the end, we can contribute to them receiving the drug and not some other factor. So these are the other factors in the middle that we say we control. We make sure that, and when we say control, we mean make sure that they're the same for both the control group and treatment group. So like diet, I'd probably take these people and I'd probably make sure that they all eat the same. And I would even measure how much they're eating, and give them all the same amount to my best of my ability. And I'd make sure they all get the same amount of exercise. I'd make sure they all came in with a very similar, if not exact, perfect health records or whatever. And then exposure to pollution, I would probably make sure that this experiment, they kind of leave wherever they're at and they kind of live in the same community for a while. Like that way, if there is like pollution, everybody, the control group and the treatment group are getting an equal exposure of it. It's not like one person is living by, I don't know, a nuclear plant where there's lots of pollution or whatever. I don't know. I don't even know if there's pollution around a nuclear power plant, but in a situation that has more pollutants than the other people. So we want to make sure that everything, like I said, we're controlling it. We're making it the same for everybody in the experiment. And like stress levels. So maybe when this experiment is being performed, maybe I would take everybody out of work and it'd be like a vacation like setting so that, because of course, stress levels affect your health. And it could actually make you sick or whatnot if you have a lot of stress. So that is why this is what the setup of an experiment would look like. You would control some factors, and then the only different things would be the drug or receiving the drug or placebo. Then what you do is after the experiment, after they receive coffee for however long you wanted to observe them drinking coffee, or receiving the treatment, maybe, I don't know how long it is, 3 months or 1 month or whatever, you would collect the data from everybody who's on the treatment group and be like, okay, how is your health? And I don't know how you would measure that, blood pressure, their say of how they're feeling. I don't know how you would measure it, but you'd measure their health in some way. And then you would compare that. You would look at the control group and you would do a summary. You talk to each person and see how their health is. The doctor would check them up about their blood pressure, their antibodies in their blood or whatever, however doctors check overall health. We would have that evaluated for each person. We would make like a summary of the results of the control group, summary of the results for the treatment group, and then we would compare those two. So overall, maybe somebody in the treatment group had a health score of 8.6 and from 0 to 10. And then maybe overall, on average, people from the control group had a health score of 6.8 or whatever. If that was the truth and a higher score meant better health, then we could say at the end that, well, that the treatment, the people that were receiving the drug or coffee or whatever it was, the treatment is in fact making people be healthier. Well, we say, I'm gonna say, we'll say that with a grain of salt, that it's possible that, I would say rather this, that it's possible that the drug or treatment is making you healthier, possible. We have to, I'll talk about that later, but we have to kind of look at, a designed experiment is not perfect science. There could be flaws, and we'll see. I'll talk about that later. So we never say that this causes this. I know it for a fact. We say it may cause that. So anyways. So that's a controlled study, is a study in which the subjects are divided into the treatment groups and control groups, like I showed you. The treatment group receives the treatment. I already poked out. The control group does not. And then something else that's important is we want to keep that idea of random sampling. We assign the subjects to the control group or the treatment group based on random chance. So, and ideally what they're doing to do there is any other factors that we can't control, like genetics, like maybe someone is just destined, I don't know, they're in their genetics, they fight off colds better, they have better health. I don't know. Ideally, like those would be equally found in the control group and the placebo group. Okay, if they're randomly assigned, and it avoids like experimental error, like by the study person, like. All right, and then a controlled placebo study is a study in which the subjects are divided into treatment and control groups. I kind of already said that, but placebo groups. A blind study is a study in which the subjects themselves, that's the people who are, that the experiment is being performed on, they don't know if they're receiving the treatment or placebo. And that's ideal. That's not always possible. Because if it was like the treatment was like coffee, like maybe if somebody could taste the difference between real coffee and some fake substitute that we tried to put in there. So whenever possible, we try to make studies blind, at least for the subjects. Now, a double-blind study is a study where neither the subject, maybe receiving the treatment or maybe possibly the placebo, or the researcher themselves that's recording down the results, neither of them know if this person is really taking the drug or not really taking the drug, really just taking the placebo. And that's an important thing to have if possible, to be a double-blind study. And the reason why is because researchers somewhat, they may have been studying this drug all their life. They really have a lot invested in it working. And maybe they really want to be an honest person, but when there's something kind of sort of up in the air, when somebody says, I sort of feel okay, like maybe they'll be more willing to give them a higher health score if they knew they were in the drug group, because they really deep down, they want to see this drug work. And maybe it might be intentional, or it probably is unintentional. And that's why they want to blind the researcher, because any unintentional skewing up of the results, that we want to avoid that. All right. So that's about experiments. And now I'm going to move on to talking about how sometimes we can't always trust what research says. So this is an example from your textbook. It says, is hormone replacement therapy, HRT, is it good for you? Hormone replacement therapy is a therapy given to like menopausal women, like they're experiencing lots of really bad symptoms as a result of their period stopping. And so doctors will give them like a replacement drug to help their body like wean them off of estrogen and the drugs that their body used to make naturally. So that's what the hormone replacement therapy is. But look at what all these studies were done about it, and let's look at what they say. In 1985, good news. The Nurses' Health Study reported that taking HRT, this hormone replacement therapy, decreases your chance of having a heart attack. Wow, so that's good, right? And then, oh my gosh, in 2002, bad news. The Women's Health Initiative study found that taking HRT increases your risk for heart disease and cancer. Oh my gosh, so which one is what? What is going on here? Like, how come, like 10 years later, you changed your mind? You said it was good for us, now you say it's bad for us. What the heck is going on, But anyways, in 2007, there's the mixed news. The Women's Health Initiative's follow-up study reported that HRT is good for your heart if you start taking it during menopause, but it can hurt your heart if you start taking it after menopause. Oh dear. Then in 2009, bad news, the Women's Health Initiative follow-up study 2 reported that HRT significantly increases a women's risk of heart disease and breast cancer for menopausal and postmenopausal women. Oh my gosh, like what is the real truth on this matter? Like you keep going back and forth, like what's going on? So in 2013, there's received mixed news. The Women's Health Initiative follow-up study 3 reported that HRT is not recommended for women postmenopausal, but it's okay for a short time during menopause. So it's like, what is it? Is it good for me or is it not good for me? Or what the heck is going on here? And so we ask ourselves, why is there so much confusion when we come to like, something, try and determine if something is good for us or not? Like, how come there's so much confusion? So the answer to that is it is very complicated. And it's the reason why we don't have a cure for cancer. We don't understand what causes cancer to this day right now. Like, it is very, very complicated. There is a lot of different factors that may be coming together to make one person get cancer while the other person doesn't. There might be, or there's just a lot going on. So it is very complicated and to definitely identify a cause and effect relationship. For one thing, the setup is made by men and women who can make mistakes, who forget to consider all the different factors, or maybe there's unknown, undiscovered factors that actually apply and make a difference in the study. It is and the other thing is it's very hard to differentiate between a correlation, and that is in a correlation, a relationship where X increases, Y also increases. So, and that's what a correlation is, and I'll show you an example of one in a minute. But it's hard to differentiate between a correlation and a causation. Causation is where one thing causes another. The correlation is just where the two things tend to increase together. So here's an example of a correlation. Ice cream sales increase when crime rates increase. So we can follow it year after year. As if you see crime rates will start raising, also ice cream rates will start raising. Like ice cream sales also start rising. So does it mean that that selling ice cream should be illegal? So does selling ice cream cause crime? Like, of course not. That's ridiculous. Those two things are what we call, they're correlated together. And there's a lot of different it's hard to identify really the relationship between two variables. When we see both of them increase, let's talk about some of the things that could be happening. There are lots of different possible relationships. So it could be that like just X and Y are just positively correlated, and it's just a random truth. In fact, there's a lot of things that are positively correlated, like they both increase at the same time, and they're totally random and not related to each other. So it's just like really weird. But anyways, also there's B, that it could be that actually X does cause Y. Or C, that Y, it could be the Y that's actually causing X. Or it could be that they have a common thing that's causing both of the X and Y to happen. And I'll show you an example of that. And then there could be like two correlated things that are, one correlated thing is causing X and the other correlated thing is causing Y, but those two are correlated to each other. So there's all kinds of reasons why it may appear that one thing causes another, but it not be the case. So anyways, let's look at this example. Is coffee good for you? So researchers have observed and followed a group of people to find out how coffee affected their health. They observed, so it should be they there. They observed the number of cups they drank and also noted their lifestyle choices like exercise and eating habits. When researchers now on a side note here, when all researchers do is observe people, that's called an observational study. And ideally, we would have a clinical study or a designed experiment, and that's what I described to you here, a designed experiment, because or we called it a clinical trial, because the researcher decided who is going to get the drug and who was not, and they were also told exactly how much of the drug they should be taking and all that. And these people were told not to take the drug, and so people were, given direction as far as the treatment, how much and how less to have the treatment. That's a designed experiment. Now, alternatively, we can have an observational study. And that's what's going on here with this coffee study. And you may ask, well, why would I do an observational study if I could just do a design experiment? Design experiments are more expensive. And you have to have people willing to subject themselves to this experiment. An observational study, you can just follow people and just observe what they do. And it's a lot more ethical sometimes in some situations. Like if I was trying to study whether, the effects of smoking on pregnancy, I probably would not want to take, women and force them to smoke while they were pregnant. That would not be ethical, right? But I can follow, women that have chose to smoke while they were pregnant and follow their pregnancies and see how they turn out and stuff like that. Okay, so there's reasons why we want to choose an observational study. Anyways, they just observe. When researchers just observe people, as opposed to asking them to drink a certain amount of coffee or manipulating how much or they have of exercise or other things, then it's called an observational study. So the initial study showed that coffee was bad for you, leading to a shorter life. People had more overall, when they observed their health at the end of the study, they found, hey, these people are not as healthy. And they followed these people for quite a while. I don't know if it's like 12 years or whatnot, but they followed them. And but this is not the end of the story. So the initial study showed the coffee was bad for you. Then, after the study was done, they realized that coffee drinkers are more likely to be smokers. So looking back at this picture, when they separated people kind of into two groups, which you do in an observational study too. The ones that don't drink coffee, the control group, the ones that do drink coffee, the treatment group. And then you would, at the end, you're going to compare their health. Well, they didn't realize that when they had people in the treatment group, they actually had a higher ratio of smokers in the treatment group. So these were a lot of non-smokers over here, and these were a lot of smokers. So smoking was actually what ended up making this treatment group more unhealthy. It wasn't their coffee drinking. So if there's another factor that affects the results of a study, that's called a confounding and confuses the cause and effect relationship. We call it a confounding factor. And that's what happened. They redid the study and they made sure that there's no smokers at all in the study, and that they compared just coffee drinkers that were non-smokers to non-coffee drinkers that were non-smokers. And when they did that, they found out that that actually coffee was better for you, that people that in the treatment group were healthier. So the thing is, like, this may not be the final decision on coffee drinking. Like, maybe there's going to be another study, or maybe there's going to come out later on that there was another confounding variable, or maybe there's some error in the way we did this coffee experiment or study. So maybe I would say we're going to still take this with a grain of salt. And they did say here that the original study was flawed. I mean, the study, I think both of the studies were flawed. The researchers only recorded the lifestyle habits at the beginning of the 12 years, I guess. And then, but these people change their habits over a 12-year period. They're definitely going to change, or maybe they became smokers, or maybe they became drinkers, or I don't know, of coffee. So, or maybe they became exercisers, or maybe they didn't become exercisers, so there's a lot of things that could have changed that they didn't really, they just took down their habits at the beginning. And then there were other confounding factors that they failed to control for. There was high blood pressure, which affects your health, of course. And there was high cholesterol, which also affects your health, but they didn't really control for that. So they didn't make sure that it was the same in both groups. So maybe maybe one of those other factors are what's really skewed the results in the end of that experiment. So is coffee good for you? So, I mean, at this time, they believe it is. So we could enjoy your Java right now, but who knows what they're going to say, right? I don't know. I would say we need to take it with a grain of salt. So here's the conclusion I have for you. We need to take the results of a study with a grain of salt, just like I said, which means you need to question them because they may not be the end of the story, just like with the coffee story. Sometimes they are wrong. And your textbook talks about this Alacor example where they were just flat out wrong and they published wrong results and they really scarred and hurt the Apple industry. You can read in your textbook about it. And you never know if there's a confounding variable that exists that they didn't know about at the time of the study and that maybe still has not been discovered yet, So one thing is we should never use results of an observational study to conclusively determine that a causational relationship exists. And even if we're using a designed experiment, you see it, we say may cause. We don't say something definitely causes something else. We say may cause. Because we know that these experiments are not flawless. All right. There was a 2-week study done on the effectiveness of a new oral medicine. In the study, 369 people were randomly divided into a group of 201 taking the oral allergy medicine and a group of 168 taking an oral placebo. Participants were non-paid volunteers from Texas and didn't know which group they were in. They spent a minimum of 10 minutes with exposure to a trigger allergen each day. Their allergic reactions were recorded by the researcher. So describe the following in the study. Who is the target population? That is, at the end of the study, who do we want to make a statement about? All right, what is the target population? What do we want at the end of this? We want to say, oh, well, this allergy medicine works for these people. So I would say people with allergies. And usually they want to be more exact, like people from the United States with allergies. And you might even add from Texas, depending on how exact they want you to be. And usually we want to be exact about our target population because we want to make sure to get people sampled from all the people that were the target population that we're talking about. And so probably I would say people with allergies from Texas, because all their volunteers are from Texas. And the allergy problems might be just a Texas thing. Or maybe this drug only works for the particular allergies that are affecting them in Texas. So anyways, so the sample frame is volunteers from Texas. The sample is 369 people from the volunteers from Texas. The treatment group, it would say they were divided into 201 taking the oral allergy medicine. So that's the 201 taking the oral allergy medicine. The control group was the 168 people taking the oral placebo. And I would even add what is the possible confounding variables? So to help you answer this one, we should even ask like what is the response variable and what is the explanatory variable and what is the response variable? So what is possibly causing what in this experiment? And a hint is what did they record? Because they always record the response variable at the end. So it says their allergy reactions were recorded. So before I go over the possible confounding variables, we have to be clear about what is the response and the explanatory variable. So I'll just write the explanatory variable or the treatment so whether or not they have a reaction, we're interested in whether the medicine causes the reaction or not, right? So the explanatory variable is the allergy medicine. The response variable is the allergic reaction. Hopefully, if the medicine is working, they have no allergic reaction, right? So what other things could either affect you having an allergic reaction or not? So that's the question. When they ask what are the possible confounding variables are other things that could affect whether you have an allergic reaction. So I guess like, to me, I know like allergies can be very specific. Like some people are allergic to peanuts while others are allergic to, pollen. So, I mean, not everybody is allergic to everything. It's just because, so to me, I think it might be confounding if people are allergic to different things. So if people are allergic, so I guess if people have different allergies, if people are allergic to different things, there's a possibility that this thing that they're exposing them to, they're not even allergic to that in the first place. So maybe they're not even taking the drug, or the drug isn't doing anything. They're just not allergic to that, and then we're recording down, oh, look, the drug is working because they're not allergic, but they were never allergic even if they were took before they took the drug, right? That would be terrible. And it could be, I think too, their diet, because maybe there's something else in the environment that they're allergic to other than the thing that you think that is causing the allergic reaction. There might be other things in the environment. Maybe it's, I don't know, molds, like I know I had a girlfriend that was really, really, or maybe cleaning supplies or something like that. She was really sensitive to cleaning supplies and really sensitive to like if you left a washcloth to hang in the bathroom and you wrung it out and everything and you just let it hang there. She just thought it was moldy and she was so allergic to it. So like, I think another problem with this study that you'd have to make sure to like control for is other possible allergens in the area. And also you have to think about other things in the environment that prevent allergy from happening. Like maybe there's a soap that you're using that is scented that masks the smells and scents that make the person allergic. So maybe there's other things in that environment, or maybe just the air quality, because maybe the person, we thought they were allergic to just the pollen, but maybe it was a mixture of the pollution and pollen together that was really irritating them, like, so um I would say other confounding variables are just um like I said, things that could either cause a allergic reaction or things that would dull an allergic reaction. Like maybe there's certain foods that they're eating, like honey. I know if somebody has honey, your honey can actually help somebody overcome their allergic reactions. It can have a positive effect on somebody. So um, I would say another possible confounding is just other things like honey that would lessen your allergic reaction. So other things that would cause reactions and other things that would lessen an allergic reaction. And probably like just their overall health level, maybe their exercise, maybe their stress level. I think sometimes we're down and then our like allergies hit us worse, or other colds, right? Somebody could come in and get a cold and it could worsen their allergy, their allergy reactions. Okay, so other things that lessen the allergic effect. Or maybe somebody had, like I said, maybe like pollution. Maybe somebody was exposed to pollution at home. They're not exposed to it here at this new environment and wherever you do the experiment. Why can this be called a randomized controlled placebo study? Well, it sounds like, I mean, even though the people volunteered themselves to be part of it, the participants were non-paid, okay? They spent 10 hours, wait, it says up here, they were randomly divided. That's why. The important thing is not really how that sample came about having that sample so much. Ideally, we would have used one of the methods that we talked about in the previous class, but sometimes for a lot of times for studies, it's just not possible. But the most important thing is once you get some people to be a part of it, to randomly choose to divide them between the control group and treatment group. So because they were randomly divided, or they were randomly assigned to either the control group or treatment group. Okay, was this experiment double blind, blind, or neither? So I know it talks about participants were non-paid and they didn't know which group they were in. I would say this one was blind. I don't know about double blind because it doesn't say anything about the researchers knowing which group they were in. So I'm going to say this was blind. Since the participants or subjects, a lot of times the people in the experiment being either receiving the drug or not receiving the drug, they're the subjects didn't know whether they are in the treatment group or not. And that is it. Let me just make sure on the next page. Okay, and then I go on. I have another in the notes. I go on and I talk about different studies that we and different ways that we should be all kind of, when we think about a study that's done, we need to think about where they got the data and what possible things could have gone wrong, and and just it would be good. It would be a good idea for us to look at the way they conducted the experiment to kind of before, and that's what I kind of do before I read headlines, and then I kind of like, you know what, I would need to look into that further for me to really believe that. I want to see what the research they did, the way they conducted the experiment and stuff like that. So you can read on after this. I have a lot of, I show a lot of or share a lot of experiments that just more reasons why you need to be skeptical about the results in a research experiment. All right, have a great day, guys. Bye.